Welcome to our exploration of auto-image enhancement techniques and evolving methods. In this digital age where images have become a primary means of communication, ensuring their quality and clarity is of utmost importance. Enter the realm of auto-image enhancement, a field dedicated to improving image quality using advanced computational techniques. It's about making images look better, sharper, and more vibrant. But how does this magic happen? We're going to dive into a range of topics to answer that question. We'll start with the evolution of auto-image enhancement, starting from manual adjustments to automated algorithms. We'll then explore power law gamma transformations and how they play a crucial role in image enhancement. Later, we'll touch upon the use of convolutional neural networks and neural models in auto-image enhancement and how platforms like TensorFlow and PyTorch are instrumental in this process. Join us as we delve deeper into this fascinating aspect of image processing. Image enhancement has come a long way since its inception. In the early days, the process was purely manual, requiring a keen eye and a meticulous hand to adjust brightness, contrast, and other image attributes. With the rise of digital photography, software tools made this task easier, but it still needed human intervention. However, the advent of artificial intelligence and machine learning brought a paradigm shift. Sophisticated algorithms could now analyze an image and make necessary enhancements automatically. Techniques like histogram equalization, gamma correction, and convolutional neural networks started gaining prominence. These automated tools didn't just improve efficiency, they also brought a level of precision unattainable by human hands. They could detect subtle nuances in color, light, and texture, making the images more lifelike than ever before. Today, auto-image enhancement is not just about making photos look good. It's about making them tell a story, evoke an emotion, or convey a message. As technology advanced, so did the methods of image enhancement. Scene script. Let us now understand the concept of power law gamma transformations. At its core, a gamma transformation is a simple yet powerful technique used for adjusting the brightness and contrast of an image. It does this by altering the pixel intensity values of the image. What makes power law gamma transformations unique is the use of an exponent, also known as the gamma value, to control the transformation's intensity. You can imagine a gamma transformation as a curve, with the gamma value determining the shape of this curve. When the gamma value is less than 1, the curve will be concave, making the image brighter. Conversely, when the gamma value is greater than 1, the curve will be convex, resulting in a darker image. Power law gamma transformations play an essential role in image enhancement for a couple of reasons. First, they provide a non-linear method of brightness and contrast adjustment, which often yields more natural-looking results compared to linear methods. Second, they allow for a high degree of control, with the ability to fine-tune the gamma value to achieve the desired effect. The power of this technique becomes evident when we see it in action. Let's consider an image that is too dark. By applying a power law gamma transformation with a gamma value of less than 1, we can effectively increase the image's brightness while preserving its contrast and overall quality. On the flip side, if an image is too bright, we can use a gamma value greater than 1 to darken the image without losing detail in the highlights. The transformation's non-linear nature ensures that the brightness adjustment is balanced, preventing the darker areas from becoming too dark or the brighter areas from becoming blown out. In essence, power law gamma transformations are like a fine-tuning tool, allowing us to adjust an image's brightness and contrast with precision and subtlety. The key is to experiment with different gamma values to find the one that best enhances the image. The right gamma value can make all the difference in image enhancement. Convolutional neural networks, or CNNs, play a crucial role in auto-image enhancement. Now you might wonder why CNNs? Well, CNNs are a class of deep learning models designed to process data with a grid-like topology. This makes them particularly suited for analyzing visual imagery, which is essentially a grid of pixels. CNNs consist of an input layer, an output layer, and multiple hidden layers in between, including convolutional layers, pooling layers, and fully connected layers. The magic begins in the convolutional layers, where filters slide over the input image and perform element-wise multiplication to create feature maps. These feature maps help capture local dependencies in the original image, such as edges, textures, and shapes. But how do we teach a CNN to enhance an image? This is where training comes in. Training a CNN involves feeding it a large number of images, both the original and enhanced versions. Through a process called backpropagation, the CNN adjusts its internal parameters to minimize the difference between its output and the target enhanced image. This process continues for thousands or even millions of images until the CNN can reliably improve image quality. However, the training process is not a one-size-fits-all solution. Different images may require different enhancements, and it's the job of the CNN to learn these nuances. For example, an image taken in low light conditions might need brightness adjustment, while an image with washed-out colors might need saturation enhancement. The CNN learns to recognize these conditions and apply the appropriate enhancements. So in essence, CNNs are like image enhancement artists. They study a vast gallery of images, learn the art of enhancement, and then apply their knowledge to new images. And the beauty of it all is that this happens in fractions of a second, making CNNs an ideal tool for real-time image enhancement tasks. And there you have it. CNNs have revolutionized the way we enhance images. They've taken a task that once required manual fine-tuning and turned it into an automated process that can adapt to a wide range of image conditions. Truly, we're living in a golden age of image processing, and CNNs are leading the charge. Neural models and data compilation form the backbone of auto-image enhancement. This is where the magic happens. Picture neural models as the artists, meticulously trained to transform your images into masterpieces. These models are uniquely designed to interpret and enhance image data, with each neural network layer acting as a brushstroke, adding depth and detail to the image. Now, a good artist needs quality paints, right? In the world of AI, this is your training data. High-quality, diverse data is the cornerstone of creating effective neural models. It's the palette from which your AI artist draws its colors. But before you start painting, you need to prep your canvas. This is where data preprocessing comes in. It involves techniques like normalization and augmentation, which ensure your data is in the right format and variants for your model to learn from. Remember, the quality of your output depends heavily on the quality of your input data. TensorFlow and PyTorch have become go-to tools for image enhancement. Let's dive into how these two powerful tools have revolutionized the field of image enhancement. TensorFlow, developed by the engineers at Google Brain, is an open-source library for numerical computation and large-scale machine learning. TensorFlow bundles together a slew of machine learning and deep learning models and algorithms, making them useful by means of a common metaphor. It's like having an image enhancement powerhouse at your fingertips. Now imagine you're working with a dimly lit image. With TensorFlow, you can implement power law gamma transformations to adjust the image's brightness and contrast. This is done by applying a power law function which maps the pixel intensity of the input image to a new intensity level in the output image. But TensorFlow's capabilities go beyond gamma transformations. It also allows for the training of convolutional neural networks, or CNNs. These are deep learning algorithms that can take in an input image and process it in a way that reduces the image to its essential features, discarding the rest. The CNN is then capable of enhancing these features to produce a higher quality image. Now let's turn our attention to PyTorch. Developed by Facebook's Artificial Intelligence Research Group, PyTorch is another open-source machine learning library that's particularly well-suited for applications such as image enhancement. Its dynamic computational graph, a key distinguishing feature, allows for a highly flexible and interactive troubleshooting process. PyTorch allows you to design and train neural models specifically tailored for image enhancement. This involves feeding your model a large data set of low and high-quality image pairs, allowing it to learn how to transform poor-quality images into high-quality ones. It's like teaching an artist to perfect their craft, but the artist is an algorithm, and the craft is image enhancement. In conclusion, TensorFlow and PyTorch have not only made image enhancement more accessible, they've also increased its efficiency. These tools have opened up a world of possibilities in the field of image enhancement, and we're just beginning to scratch the surface of their potential. TensorFlow and PyTorch have made image enhancement more accessible and efficient. Pre-trained models can save a lot of time and effort in image enhancement. This is because they have already learned numerous features and patterns from vast quantities of data. Therefore, they start off with a strong foundation and require less training data to achieve optimal results. Now let's talk about fine-tuning. Fine-tuning is a process that tweaks a pre-trained model to better adapt it to a specific task. This is done by continuing the training process on the new data, allowing the model to adjust its weights and biases to better fit the task at hand. Imagine it like this. You're a skilled painter who's been taught to create beautiful landscapes. Now, you're asked to paint a portrait. You already have the basic skills, but you need to fine-tune them to excel at this new task. In a similar way, pre-trained models are fine-tuned for specific image enhancement tasks, making them versatile and powerful tools. Pre-trained models are a valuable asset in the process of image enhancement. We've covered a lot of ground in our exploration of auto-image enhancement. From the fundamentals of gamma transformations, the power of convolutional neural networks, to the implementation of TensorFlow and PyTorch for image enhancements, we've seen how these techniques and tools are transforming the way we enhance images. We've also delved into the significance of data compilation and preprocessing and the advantages of leveraging pre-trained models. It's clear that the field of auto-image enhancement is not only about improving image quality, but also about pushing the boundaries of what's possible with technology and creativity. Looking ahead, the future of auto-image enhancement promises even more exciting developments. As AI and machine learning continue to evolve, we can expect more sophisticated algorithms and innovative techniques. These advancements will undoubtedly open up new opportunities and possibilities in the realm of image enhancement. The future of auto-image enhancement is as exciting as it is limitless. Until next time, keep enhancing.